So when talking about space, you would always think of the big countries and the pioneering countries such as the United States of America, Russia, the Chinese. But actually, you would ask yourself, which role did Germany play in all of this role? And to go in a bit deeper, which role did Bavaria play? So when we take a look at the Saturn V, the most powerful machine humanity has ever built to date, there's actually a lot of German technology inside. So when we look also about, for example, the main designer, Wernher von Braun, he was one of the masterminds, or actually the biggest mastermind behind the overall design of the huge, gigantic Saturn V rocket, which brought humanity to the moon. When we also take a look at the people who surrounded him, in that case, Harry Ruppe, who was at that time a very, very famous engineer, and unfortunately is not too well known in Germany and among German engineers. But actually, on this picture right next to Wernher von Braun, so the second left to the right, second one to the right, Harry Ruppe was actually a core team around Wernher von Braun to develop Saturn V rocket. And Harry Ruppe was a German engineer, and he actually was the guy who decided that Saturn V will actually have 5 rocket engines in the first stage, the F1, which is one of the mightiest machines in itself ever built. And Harry Ruppe was also then the first chair of the astronautics chair at the university here in Munich. So there's already a lot of know-how based from the 60s and the 70s, which went into the engineering disciplines and also later on the industry here in Germany. When we also take a look at how the industry around that evolved, starting with the university research, one of the PhDs under Professor Harry Ruppe was actually Robert Schmucker. And Robert Schmucker at that time founded a research group called VAR, so a scientific work group for rocketry and spaceflight, because at that time, when he was still studying at the Technical University of Munich, he didn't have yet the access to the data and to the know-how that Harry Ruppe would later on bring to the university here in Munich. But when Schmucker was old enough to really do his PhD in rocketry, he on the side also worked on his private topics. In that case, what we see here within the rocketry research group VAR, one of the small sounding rockets, in that case one called Barbarella, one of the earliest rockets privately or in a university level built within Germany. At the same time, there was a second group not far here from Munich in Stuttgart, where a second guy called Lutz Kaiser was actually also working on hybrid rockets and small sounding rockets until upon a push from the German government, they merged these two groups on a university level, which later on brought also forward the company Ultrac, which as a fact has been the first private rocket company globally. And this was really kind of the start of the private space industry, so to say, coming right here out of Bavaria. So what we see here is really the very, very pragmatic approach that Ultrac did, trying to build a very, very low-cost space launch vehicle to bring satellites to orbit. They tried to really be very, very pragmatic, as you can see here, really going in shorts onto the rocket launch site and trying to be as futuristic as possible to really think which technologies could you actually use to make spaceflight a lot cheaper. In that case, they went for rockets which use a lot of technology from the automotive industry, for example. And on the other side, and not just from the tech side, but also from a political side, as you all know, rockets in general always create a buzz on a political level too. So when actually we follow the history of the Ultrac company, we actually see that at the end we had quite a tricky topic between especially Germany and France because Ultrac was really selling their rockets to kind of the highest bidder and to anyone who wanted to get satellites to space. So in that case, it really failed afterwards due to political issues. But still, within Munich, a few years later, a few tens of years later actually, in that case about 5 years ago, the students here from the rocketry research group VAR still pushed onwards from these technologies that were already developed in the 60s and in the 70s and went on to launch the first hybrid rocket ever built out of South America, in that case out of Brazil. And that's also the research group, which you might have heard already from a few other topics, because they were building not just rockets, but also, for example, small satellites. In 2017, and this was also the group where I was then part of, we actually went on to build Europe's most powerful hybrid rocket engine at that time, developed by a complete group of just students. So we were about 40 people to develop a 10 kilonewton HTPB LOX rocket engine, which then also sparked the interest from the commercial space industry. At the same time, we were also building Hyperloop pods as part of the rocketry research group VAR. And there a funny thing happened actually on the SpaceX parking lot. We got to know one of our then afterwards at Isar Aerospace earliest investors, Bülent Altan, who was for 11 years the vice president at SpaceX and really built up SpaceX from the ground up and developed essentially the entire electronics for Falcon 1 up to Falcon 9 and Dragon, as well as Starlink. So we really took all of that momentum, all of the know-how we had built already at the Technical University in Munich and said, hey, how hard can it actually be to build an orbital launch vehicle? So we set ourselves the goal to build Europe's most powerful privately financed and privately developed rocket launch vehicle to make it to orbit and thereby also fueling and enabling the entire commercial space industry. Because one of the trickiest topics and also the bottleneck within a huge commercialization of space is actually the access to space. Because all of these satellites in the first place need to go into orbit. And that's what our rockets do. As of the past 2.5 years, we've grown our company now to more than 100 employees, super smart engineers from engineering design through production, through testing. And we've also built up not just the team here in Germany, but actually also one in Sweden, where we're right now in the midst of building up our vertical rocket engine test rig, where we'll actually test our full flight version rocket engines that go to space and also propel the rocket into space. So what rocket engines do is essentially they take all of the fuel that's stored on board the rocket and propel it outwards with a very high speed in order to accelerate the rocket to more than 28,000 kilometers per hour in just under 10 minutes. When we now also take a brief look at not just the past, but also the future, where Isar Aerospace is going, I brought you a small video of how the future of Isar Aerospace will look like when the actual first rocket that's right now in production will actually fly to space.